All right, so here we go. We'll make the key. Some of you said the first one, the first few, you thought maybe I was trying to trick you because they were pretty straightforward. So this definitely scaled back the difficulty level. The transformation that we're looking at in the first one is a shift to the right 3 units. We can say slide right 3 units. Number 2, we're looking at, let's see, x was replaced with negative x, so that's a reflection over the y-axis. Reflection across y-axis. Number 3, now the minus shows up outside, so negative 1 times your function. That's a reflection over the x-axis. Number 4, just a plus 5 to your function. Okay, so this is a shift up 5 units. Okay, then we go to the table of values. And I want to compare them and see what happened. So I'm first going to look at the x's and look at how the x's compare. And when I compare the x's, these are the hardest ones for me when you have to look at a table and identify what happened. But off the bat, I look at the x's and it looks like the x's didn't change. So then I'm going to go to their y's and say, well, how did the y's change? Did they all change by the same amount? So in my head, I'm thinking, okay, 1 and negative 1. Okay, multiply by negative 1. 2 and 0. Okay, that pattern didn't work. 3 and 1. Yeah, once again, it didn't work. So maybe I'll start with a different one and try to find a pattern. So let's say I went 2 and 0. Well, let's subtract by 2. So let's see if that works everywhere else. 1 minus 2 is negative 1. 3 minus 2 is 1. 4 minus 2 is 2. So I've just taken all of the y values and subtracted 2. And that's a vertical shift down 2 units. Shift down 2 units. X values stayed the same. And just because the x value stayed the same, I can come up with an example where it still is a horizontal thing. But we noticed the x value stayed the same, y values decreased by 2. If you're comparing 2 tables, the toughest thing I think to see is a horizontal shift. Okay, so I'm going to just go to a new page right here and show you. Well, let me make sure in 6. Is 6 a horizontal shift? Maybe that'll articulate it, or not. It's not? Okay. So before we do number 6, let me show you why it's tough to see a horizontal shift in a table. And what I've seen it like before. I think this one will work. Negative 4, 0, 4, 8. Say those are the x values in the first table. And we could just come up with some y values. So let's say I did like 7, 13, negative 5, and 2. Let's say we shift this thing. Let's go 4 units to the... Let's go 4 units to the right. So we'll make a new table. And this is going to be f. If I go 4 units to the right, what do I put inside of f?
X minus 4.
X minus 4, okay. So if I go 4 units to the right, let's see what my table looks like. So what's this? Negative 4, 0, 4, 8. So let's say you were looking and you're like, okay, the x values stayed the same. Would we happen to know what went here? Okay, no comment yet, that's fine. Anybody know what number would go here? What do you think? Why do you say negative 5? So you're saying if you went to the other table and added 4 to all the x values, I'll just do it up here, plus 4, plus 4, plus 4, plus 4, your new numbers would be 0, 4, 8, and 12, right? So which number do you think goes in the green spot? Seven. Yeah. Which number? What does the 4 go with?
13.
4 goes with 13. I've seen kind of trick questions like that. What does the 8 go with? Negative 5. So what if imagine if I left this off? Okay. It'd be that's a really hard one to see the horizontal shift. Because you look and students want to say the x's didn't change. That you're using the same x's. And their y values just changed. Well, did their y values like go up by the same amount every time? I mean, if you compare these two green boxes, the difference is, what, minus 6? Then if you compare these two in purple, the difference is plus, what? Plus 18. And then if you compare these ones in yellow, the difference is minus 7. So that's as tricky as I've ever seen them. I don't think I'll have one like that on the test for you, but sometime you'll be like, the x's look the same, but I could still have the x's be the same, but make it be a horizontal shift. So that wasn't the one on the quiz. But students struggle with that one. Teachers struggle with that one. Horizontal shifts can be really difficult to see in tables. It can be really difficult. So we'll go back to the assessment question here. In number 6, so, it looks to me like the y values stayed the same and all of the x's changed sign. Is that right? Okay. So all of these things here, if you multiply them by negative 1, you get all of these things here. So if the x's change sign, that means you go from one side of the y-axis to the other. So that's a reflection over the y-axis. That's kind of weird. If the x's change sign, then you're actually going over the y-axis. So 7, they start you with the function rule, and you're going to go down 4 units. Okay? So f of x minus 4 equals 25 over x plus 2 minus 4? And you don't have to worry about combining the fractions and getting a common denominator. This is really what I want to see.
About that question.
Yes.
When it says in simplest form, does that say you don't have to divide the 25 by 2 to get into simplest form?
Yeah, and you couldn't just divide 25 by 2 because it says you have to divide 25 by x plus 2. So we can't just divide off part of it anyways. So you're sitting with it here, and this form is just fine. Okay.
Right.
If x would have been replaced with x minus 4, then I would have wanted you to combine the minus 4 and the plus 2. But in this case, you're looking at what's in yellow. It doesn't need to be simplified at all. Write the rule. We're going to be translated to the right 1 unit, down 6 units, and reflected over the x-axis. This has got to be one of the harder ones, I'm guessing, on the test. So we're going to go right 1 unit. So step 1 has me replace x with what? X minus 1? Okay. So I'm going to, bear with me, I'm going to give us some room here. Put that on the clipboard, we'll come back. Okay. Now we got some space. So I'm going to start with p of x equals 2 absolute value of x plus 5 minus 3. And this was right 1. So we're going to replace x with what? X minus 1. Okay, so on the left side, I don't have x anymore. That x is going to become x minus 1. On the right side, I don't have x anymore. X is going to become what? X minus 1, very good. Now I could put it in parentheses. Like a lot of times when I substitute in for x, I like to put it in parentheses. But as you see it right now, those parentheses don't serve any purpose. So I'm going to back this up a couple steps, take off the parentheses because they're not doing anything for me. Okay, now I'm gonna take a step right here and simplify. You don't have to. You can simplify in the end, but I might as well simplify here, I think. P of x minus 1 equals 2 times the absolute value of x plus 4 minus 3. So you can, like, in the middle, simplify. Okay, now we're going down 6. So that's whatever you got minus 6. So the left side, p of x minus 1 minus 6. And you got the right side. Just recopy what you have. Minus 3 minus 6. Now here's another chance. I'm going to simplify. Okay, oh, so I should write here. This was down 6. So the next line I'll say is simplified. P of x minus 1 minus 6 equals 2 absolute value of x plus 4 minus 9. Okay. And then reflect over the x-axis. And that's what? Multiply by negative 1? So negative 1 shows up on the right side. Negative 1 times, negative 1 will show up, or sorry, on the left and on the right, negative 1 times. So you can see how on that right-hand side, it's really important that I have these two parentheses, because I have two terms on the right side. I have the term in yellow, and I have the term in blue. So terms are separated by addition or subtraction. So to show that that negative 1 goes to both the yellow and the blue, I have to put them in parentheses. So 2 absolute value of x plus 4 minus 9. And then this is p of x minus 1 minus 6. So we could simplify. Or you could even leave it there. I'm fine with that. Yeah, Anthony?
On the part where you simplify, like the second step, what if we didn't simplify and kept it in parentheses? Would that be wrong?
Say that again.
Where it's the second step, that's the value of x minus 1 plus 5.
Yeah. So okay. So you're looking right here in blue, right?
Yeah.
No, because I think if you didn't simplify it, it's okay. I mean, as long as algebraically yours is equivalent to mine, because I don't think this one said you have to fully simplify. But when you get a chance to, I think it's best to. You know, it'll make my life easier grading it. You know, that's a plus, but it's probably just good practice there. So this last one, if I were going to simplify it, let me just show you how I'd simplify it, and we can be done with this problem. So if you stopped here, that's great. If you wanted to simplify it one step further, okay, on the left side of the equals, you have two terms. You got this first one in green and this second one in orange. So if you distribute the negative 1 to each of those, you'd have negative p of x minus 1 plus 6. On the right side, you have a couple terms as well. You got the blue one and the yellow one. So if you distribute that minus 1 to both of those terms, so you'd have negative 2 absolute value of x plus 4 plus 9. If you didn't simplify, that's okay. Yes. Nice work. Because you simplified it and he didn't. Nice. So were you both right?
Yes.
All right. Nice work. Okay, so that answer goes right here. Yeah. I don't know if you guys have had Mr. Gannon. He's awesome, but he made this assessment. He's got
I noticed that, and I was like, wait a minute. Why?
He's got honors algebra 2 as well. So, okay, the graph is shown below. Mr. Gannon, it's not shown below. Sketch a graph on the same coordinate system. Describe the transformations. So I'm just going to say right to. I think the sub said just maybe you didn't have to do this. If you left this off, it's fine. But let's say this was like -4 and this is -2, and you said, hey, here's the original, and then this would be the new one. I don't know if he just had you draw a general function and move it, but whether you do or don't have that, it's okay. I wasn't here to give you explicit directions. Sketch a graph of the function g of x equals -f of x on the same coordinate system. So you don't have any graphs to start off with. So I hope you said reflection over what axis? X-axis. Our x-axis. So maybe you provided an example. So let's say here's the original, and here's the new one. Notice if the point was initially on the x-axis, like these ones in yellow, well, you can barely see this, in blue, if the point was originally on the x-axis, after it gets reflected over the x-axis, it doesn't get moved. It's in the same spot. 11. The graph is shown on the coordinate system below. Well, it's not, but I'm guessing you know what x squared looks like. The function g of x equals quantity -x minus 2 squared is a transformation. Sketch the graph and then use words to describe all of the transformation. So let's use words to describe them. So what do you guys think is the first one? If you start with x squared, what happens first? Duncan?
Reflect over y-axis and replace x with -x.
I think that's a good first step, is replace x with -x. Not the only first step. So that would be -x squared now. Now, Duncan's going to make this one interesting because you got to be able to look ahead to see the correct next step. So which way does this thing need to slide now?
Left 2.
So if you go left 2, what does x get replaced with? Left 2, Duncan says x becomes x plus 2. So, but you know what? No, you might be okay. So watch, guys. This is where it gets interesting. So I'm looking back here. Okay, that's where I'm looking. I'm gonna kind of recopy it. I got a squared thing. I got a negative in front of the x. Now whatever I plug in for x is gonna go in these parentheses. Duncan said put in x plus 2. Now if you compare both things that I'm gonna put in yellow. If you compare this thing in yellow to this one, well, don't worry about the +1 right now. You might think those are different, but this is kind of that thing that Jack and Anthony had going. They look different, but they were the same. All right, watch what happens when you distribute the x. So inside you got a -x minus 2 squared now. So if your first step was reflect across the y-axis, then you then had to move left 2. If you switched the order, it would have been a move right 2 and then a reflect. So he's got reflect across the y-axis, left 2, and then up 1. Okay, that's one way to do it. If you didn't do it in that order, let's say you, let's take out this graph. Let's say you went ahead and went left 2 first. Okay, so start with x squared. Left 2 would give you x minus 2 squared, or that would have been right 2. So if you went right 2 first, what's your next step? Which axis? Reflect over the y-axis, okay. So x becomes negative x. And then your last step is what? Up 1. So you got your negative x minus 2 squared plus 1. So this thing in purple here, matches what we started with here. But so does, I gotta put the plus 1 here, so does the one that Duncan did. So I know there's a lot on the paper now. But look at what we have in green. 2 different orders it can be done in, and you end up in the same spot. But within the 2 different orders, okay, within the 2 different orders, you have different transformations. One of them had to use a left 2, one of them had to use a right 2, depending on where they put the reflection. That's kind of a big deal, and that's definitely a higher level understanding. Okay, if you're gonna earn a 4 on this target, that's going to be a necessary piece, that you understand that I can get to the end multiple ways, but if I change the order, I might have to use different transformations to get there. Okay, number 12. So you've got 2 functions in yellow here. What transformations are necessary to perform to produce the graph? Identifying which ones might not be the most difficult part. The order of them, I think, will prove to be a little more difficult. So let's look at the order of them. I'm going to make some room again. So 2 to the x. You guys have your papers in front of you. One of them was 2 to the x. What was the other function? Is there any parentheses after the negative? Okay. 2 to the x plus 3. Just like that? Okay. Okay, anybody have an idea on what the last thing should be? What do you got, Emily? Perfect. Yeah, the last thing. Last, reflect over the x-axis. So she's looking at that negative there, and she says that negative gets applied to everything. So that means all that stuff came before the negative was there. Good job. So we'll just lead up to reflect over the x-axis. So we start with 2 to the x. What's the first thing you want to do, Emily? Left 3, okay. So then we get 2 to the x plus 3. Then what do you want to do next? Nice. Down 5. Says take what you got. And then do a minus 5. And then she's already said her last step. Her last step is, hey, take that stuff in yellow, put it in parentheses, and multiply it by -1. So here's her first step, second step, third step. 1, 2, 3. Left 3, down 5, reflect over the x-axis. Duncan?
Does the first and second step, does the order matter?
What do you guys think? If you switch the order of these, does it matter?
No.
Nope. No. Diana? If you didn't say them in order, because it doesn't say so there, I won't account for it. I wasn't here and it didn't say to put them in the right order. When you get it on the test on Tuesday, I'm going to ask you at times to put things in order. Okay? So if you think, okay, well, how will Tuesday's test compare to this one? Think, well, it's very similar, except on Tuesday's test, I'm going to have to make that last step. And if I want to earn a 4, I'm going to have to be able to handle order. So, that's it. We did it. The answer to that last question was left 3, down 5, reflect over the axis. So really, good job.